The computational infrastructure we have described thus far is executed by giving one command, writing one command into the command prompt. And then it will typically analyze the whole dataset. It produces an output to the console as we saw in the earlier presentation. And it produces all the output files, the raw output data. But as the projects and the model get more complex, handling and managing all of this and understanding what the model is doing can become quite difficult. And one of the ways that I have myself made this task a bit easier is by using a graphical user interface. And there were several principal reasons why I implemented this type of interface. The main reason originally was that I wanted to create also phrase structure images from the output of the model. So originally it was because I was so tired of drawing these images myself. It's a quite big issue when you analyze, for example, 1000 expressions. But there is a more subtle reason, which is that I really don't want to draw the images myself, because that involves kind of a human intervention. The result will not be a raw output, but some kind of illustration. So I wanted to make a program that would draw these free structure trees automatically from the output for me, and that I could use these pictures also in published research papers. So that was one of the original reasons. But then I slowly expanded the program so that it could help me with many other tasks related to the supervision, management and maintenance of the whole system. And it's well known that for us humans, sometimes reading a visual presentation is more easy than reading some type of symbolic string, especially if you are dealing with very complex objects. And an additional thing is that when I have the output of the model in visual format, I can then use the mouse and click the elements in the phrase structure, for example, and just directly see what features it contains and what type of calculations my model is doing in connection with that element. So for example, let's say that I'm developing some type of new dependency into the theory. Some type of search, for example. Search algorithm that is trying to imagine it's creating agreement between verbs and subjects. So there has to be some kind of search in the phrase structure so that we can locate the relevant elements. Now, often when we start to do this, our first attempts don't produce the results we wanted or expected. And sometimes it's very difficult, extremely difficult to find where the problem is, because you sort of don't see, or you can't experiment, or you don't really have a good grasp of what the model is doing without painfully adding ad hoc print and logging commands into the code. And the easy solution for this is that we create the graphical interface which allows me to see the phrase structures on the screen, and then I can click items and I can see what the model is calculating, what type of dependencies the model is creating for that element, so that I can go into the screen and click different phrase structure nodes and see what my model is actually calculating in connection with all those nodes. And that's a very easy way of finding out what's really going on, where the problem is. So now I will just quickly illustrate what type of graphical user interface I have done for myself and what kind of things you can do with that. And this is not really what one would say a fully functional system at this point, because I have just added functions and options as I was needing them. And I often make a lot of changes into the background, onto the engine and the syntactic model. So again, I saw that not everything was working as I expected. This would require a lot of systematic debugging and really the type of professional software development for which I don't really have so much time. I would be happy to do, but I just don't have the time. So, but this is just an illustration of what is possible with quite little coding. And I have implemented this by the graphical user interface tools available in the standard Python. Tkinter it was, I think, what was the name of this library. I think it was easy to use, although it can produce only very basic user interfaces. I think nothing fancy, but why would we need that? So what happens here is that if I launch the script without giving any special parameters, and now I'm talking about my own model as it exists when I'm doing these videos, it will just run one complete study. Maybe in a later presentation I will explain how the studies themselves are configured. But then alternatively I can give it a parameter or extra argument app, and it will, instead of running the whole study, it will open this graphical interface that you will see now into here in the screen. So this is an alternative program where I can use the same functions, the same underlying Python program, so that I can here I can load studies, meaning study configurations that will then analyze different data sets and different settings and assumptions, and the configuration is a bit different depending on the study. I can run the whole study from here. I can run the study so that it generates also images from the outputs if I want to use them in my papers, if I want to check that they are correct. I can create a new phrase structure image from scratch. I will show soon how this would work. There are some settings and help. There's not much here. We don't need any help. Who needs help? Here in the upper right panel, it loads the current dataset based on the study that we are now that we have loaded by default. We can change this if we want. But here is the dataset, and I think that this is the critic dataset we already looked into an earlier presentation. And I can click now, or let's me go explain what the other columns are. So here is in the bottom left, I have all the speaker models that the script has created. So Finnish, Italian, Estonian, English, Hungarian, and then there is X, which I use to create artificial ad hoc lexical elements for testing and for some illustrations, for example. And this is important because the speaker models, as I just showed, they are created at runtime. There is no file which specifies them. So this shows the lexical items for Finnish speaker model. So I can check that the script is constructing it in a correct way. Or if there is a problem, I can come here to see if the problem is in the lexicon. I mean, this is easy way to do it. And if your model would have different rules for Finnish speaker model, then those would be shown here also. All of this information is of course also in the derivational log files, but it's much more harder to find from there. These files here are my lexical files, the original files from where I read the root lexicon and redundancy rules and inflections and universal functional morphemes and others. So I can check that those files are acquired correctly. And then here in the bottom right, when I'm running an analysis, here I will have the results. For example, if the sentence is ambiguous, I will have here several fields for the results. Now we have only one. This is the first sentence here, Pekka malasi aitaa, which was the Pekka painted the fence or some fence. And here we have one solution and we can start looking at the predictions. Here is the syntactic analysis in symbolic form, thematic rows, agreement, predicates, aspect. These are discourse features, operator group and semantic spaces, speaker attitudes, assignments, and so on and so on. All sorts of things that the model is predicting I can check from here. I haven't used that so much. I prefer to look this information from the derivational log files, but here it is anyway. Now if I click this item or any item here in the dataset, the model will launch the script and only analyzes that one or derives that one expression. Let me try if it works. This time luckily it works, so my demonstration is not completely. So then it opened me this window where I can now visualize and I see the result in a visual form as a phrase structure image. But this is exactly what the theory was creating when it was deriving this sentence. And here we could, if this program would work perfectly, but this system was not working, we could scroll the derivation forward and backward and go to the beginning. We could see how the derivation proceeds step by step. And if the system finds several possible analyses, it's ambiguous, then we can see them all here. This is the first accepted logical form for this sentence. If the sentence doesn't have any derivations, then you will see nothing here. You just have to go to the derivational log file to see why every possible attempt was blocked. So that's a kind of a problem that you might want to also to explore failed derivations. I have to do that perhaps at some later time. I don't need it now myself so much. So what I can do here, I can do many things. This is just an image. I can also edit myself in various ways. These buttons and options here are for that reason. I will show soon how we can create this type of image from scratch. But there are some things that I wanted to show. One is this, that I can pick up now constituent here. I picked this one. And then I can open a window where I can see its features. And here is a list of all sort of, here we have listed this, under the geometry, different type of dependencies and properties that my theory is calculating for that item. This is just a partial list of things that I was at some point interested in when I was checking that the model is working correctly. But you can have anything here we would want. It's very handy that I can examine these items like this and see what my theory is really, what type of calculations my theory is really making with these elements. So I think that this was what I wanted to show about the visualization. why there is this editing option? Simply because this automatic phrase structure drawing algorithm sometimes produces bad results, especially with a very complex output. So we can, for that is the reason we can move these things and do all sort of, we can change these texts here and remove them, and we can, for example, we can use triangles and all sort of things that make this a bit more easy to produce nice pictures. But I have also used this program to create phrase structures from scratch, because basically the underlying engine is the same. It just doesn't get any input from the model or the execute from the script. It just creates this empty picture. So I will show this how this works. But this is it's quite useful thing to have and makes many things fast. So I'm starting with the empty canvas. Then I can start expanding it, and we can add labels, and it will automatically create me labels for complex elements, and so on and so forth. We can also override this automatic labeling if we want. So I can just here select this, and I can say, let's say it's called XP. So now it's over XO, whatever. Now it's overrides the calculations that come from the theory itself. And then we can, of course, make all sort of dependencies. We have a chains, this kind of forward arrows. Then the several properties, we can have bi-directional ones, that arrow goes to both directions. We can have we can write the labels like this, and so on. All sort of things that we can use to draw elements. Then we have, of course, here I can add phonological information, John, glossing, John. We can have features, third person singular, and so on. And of course, this can be moved, and then we can flip them in the other way. Let me try to flip it. So here you see that there was some problem. I flipped it and it actually was shrinking it, which was not what we were supposed to do. But I can correct it by using that button. And in this way, it's possible to do phrase structures that are standardized. So all the spacing, all the font sizes, they are all always according to a standard template. Currently, I don't have, I only have this one template, but it would be easy to add, for example, if I want to mimic linguistic inquiry, Cambridge University Press style, all these styles. It would be a simple thing to make it so, but now I haven't, just have I'm too lazy and don't want to use my time. Of course, this is not a fully fledged graphics program. So if I want to have something really special, then I will simply grab this image from here and then paste it into other program where I can add graphics, a drawing program that I can use to add whatever I want. So that's then an option. I have some templates here. So I can start, if I'm making illustration, I can start from a TP, for example. It gives me this kind of regular starting point where I don't need to draw everything myself. There's a lazy people do this. Okay, dependencies. I also added a curved chain like this. So sometimes it's easier to make a distinction between rectangular dependencies and curved dependencies so that they illustrate different things. There's a phrase structure, all sort of things we can build more nodes left, because what I was showing you was just expanding it gives the two constituents. String, we can remove constituents, we expand, yeah, we can delete. Not functional, seems to see there. Flip structure is something we turn them, as I already showed. We can have adjuncts marked differently, move constituents. Then we can mark some nodes as a special node. If I want to do an illustration, I can show that that's there. Compress, we can make triangles. We already showed that. Squeezing, widening, we can move. That was already. Here we can have the labeling, so we can have a custom labels, superscript, subscript, phonology. We can mark ellipses. So this, if I have, I think, let's see if it works. If I have John here, then I should be able to mark it as deleted by ellipses. It worked. So it makes it strikes it over. And then what else? Closing custom free text. Well, that's about it what I have now. And then there are some stylistic decisions that we make. For example, how we represent complex words. But it was not working, so I'm not gonna show what it is doing. It's not doing anything, basically. Anyway, you can see that when you're working with complex projects and complex data, this type of approach eventually will save you a lot of time. It produces you images directly from the output, so they are raw output data, not illustrations, which is very useful and good thing to have.